Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 2nd, 2025, just yesterday. It introduces a new framework that can automatically color animations that are at least 5 times longer than what previous methods could handle. The paper is titled LongAnimation, Long Animation Generation with Dynamic Global Local Memory, and it tackles a major headache in the animation industry, keeping colors consistent over very long scenes. This paper proposes a new model that uses a dynamic memory system to maintain that color consistency. Also, the authors shared their full implementation on GitHub. If you take a look, you'll find the complete source code, of course, but also detailed setup instructions, inference scripts, and links to the pre-trained models you'll need. It really has everything to get you started on generating your own animations. Alright, so to understand how they achieve this, the first figure gives a great side-by-side comparison. On top, you see the old way, the local paradigm. It processes short video segments and just overlaps them. But as the example frames show, the character's hat color drifts over time because the model lacks a long-term view. Below that is their new dynamic global local paradigm. It uses a key component called the dynamic global local memory. This system combines a global memory of the entire scene's color palette with a local memory of the current segment. The result is striking. High, long-term color consistency, with colors staying stable across hundreds of frames. Okay, so this next figure breaks down the model's architecture. Part A shows the full training pipeline. You see it takes a text prompt, a reference image for color style, and the animation sketches. The process then uses 2 key components. First is a module called sketch.dit, which is purpose-built to process the reference image and sketches. Then, for subsequent frames, the real star, the dynamic global local memory. It uses a long video understand model to look at the historical video and feed that information back into the current generation, keeping everything consistent. Moving to the results, this figure provides a really clear qualitative comparison. On the far left, you have the original animation, the ground truth. Next to it is the result from their LongAnimation model, followed by other methods. You can see how their model keeps the colors perfectly stable over 300 frames. But if you look at the other models, the character's dress and the leaves change color completely. This is partly thanks to a component called the color consistency reward, which ensures the video's low frequency features, which basically represent broad color information, stay consistent. This table then details the quantitative results, backing up what we just saw visually. It compares their model against others on both short animations of 14 frames and long ones of 500 frames. They use several metrics. For example, one is Fréchet video distance, or FVD, which measures video quality and consistency, where lower scores are better. Looking at the results, their model achieves the best scores in bold across the board. The improvement is especially dramatic for long-term videos, with nearly a 50% better Fréchet video distance score, really proving its ability to maintain that long-term consistency. To see how the different parts of the model contribute to those strong numbers, this next figure shows an ablation study. That's a process where researchers test their system piece by piece to see what each part does. The baseline model, sketch.dit, has some clear flickering. You can see the girl's hair color isn't stable. But then, adding the dynamic global local memory fixes that major inconsistency. And finally, adding the color consistency reward refines even smaller details, like getting the headband color just right. It's a great visual of how each component builds on the last. So as we've seen through all these results, the LongAnimation framework successfully tackles a major bottleneck in automated animation, keeping colors consistent over long periods. The key takeaway is their novel dynamic global local memory. By blending a long-term global memory of the scene's colors with the immediate local context, it avoids that color drift that plagues other methods. The results really speak for themselves, a huge jump in quality and consistency for animations up to 500 frames long. It's a promising step for the animation industry. That's all for today's AI Research Roundup. Thanks for tuning in.